seeing how this looks. You know, if all of these look like garbage, then I'll just reboot and go to a modern machine. So I have a plan, sort of a plan of what I want to do with the software here, but it could be that this was just a very, very bad idea. All right, Nerdshark says, looks good on 720p. I'm loading up Twitch right now to see. No choppiness. Yeah, there's no choppiness, but oh, okay, now I can read it now that it's scaled in. Yeah, you can read it now. So I guess this would be all right. So if you're just joining this stream, having a couple people help me troubleshoot here. I'm using a 10-year-old computer, an old Mac Mini. It has an i5 in it. It has 16 gigs of RAM and an SSD drive. And actually this Mac Mini, I built 4 Pluralsight courses with this Mac Mini. And I had a lab set up too, so I can't really say I built them all entirely on this Mac Mini, but I did all the video editing and rendering and audio editing and all the stuff on this Mac Mini. I love this Mac Mini, and I just decided to see, yeah, it was probably top of the line. I think I paid $1,200 for it 10 years ago, and I definitely got $1,200 worth of use out of it. Like I said, I built those 4 Pluralsight courses with it. And I did a lot of RDP into a rack. I had a rack server set up that I was spinning up IES on and stuff like that. But I got a lot of mileage out of this thing. And then a couple of years ago, I tossed it aside. I started using the Digital Storm workstation. And then recently in January, I got the M1 Mac Mini, which is pretty cool. For the most part, I'm starting to get annoyed using it because of the mouse dragging issue that I've been having. I put 3 different mice on it and they all do the same thing. And I have to rescale the images once in a while, so it's a really annoying machine to use. But it's pretty fast. It's faster than this Mac Mini, obviously. But for some reason, I just got a wild hair and I'm like, I'm gonna stream on Saturday and I'm gonna use this Mac Mini to do it with. So I just installed everything, set it up, made sure I could compile a hello world and started going. And this was an awesome machine way back in the day. All right, I'm gonna check something really quick, delete a couple things, and we'll get started with the actual stuff. The stuff we want to do, which is work on this hot car project, which has been a really fun project. All right, I'm going to delete these tweets from Twitter. So I'm not spamming Twitter with several different live streams that are all junk. Because today I decided to stream to Twitter, LinkedIn, Facebook, all the places. There we go. Now we're golden. Now we're running. And I can see on here, Nerdshark says, I've always been a Windows guy, but plan on getting a Mac for Final Cut Pro. Waiting on their next in-house chip. Very smart move. No, nothing of coding, but here to support the stream. Maybe thanks, Nerdshark. I really appreciate that. So I've always been an all the things guy, but so in my career, I've been a software engineer and software developer for about 20 years now. I got my first paid real programming job in 2002, so 19 years. But I started out with Linux, and I started out doing Linux stuff because I was a Linux system administrator, did a bunch of Linux stuff. In 2008 or 2009, I transitioned into C# and .NET, and absolutely loved it. Surprisingly enough, even being a Linux person, I went into C# and .NET and did that for around 10 years. Absolutely love it. So that's why I'm so excited about .NET Core, is because I love being on Linux and doing Linux stuff. I love C#. It's one of my favorite languages in the entire world. And I can do C# on Linux now. So it's .NET Core, which will soon just be .NET, is really awesome. And what I usually recommend for people, and I've used Macs intermittently in between. I use Macs at work now, and I have that Mac Mini. What I usually tell people is, these days in 2021, your operating system really doesn't matter anymore. It used to matter. It used to be like, well, you're going to have to go on Linux to do X, or you're going to have to go on Windows to do X, or you're going to have to go on Mac. The only thing in your statement that says you need a Mac is Final Cut Pro. Final Cut Pro is an amazing product. It's great. It's used by all kinds of professional folks all over the place. And I have never tried to run Final Cut Pro on Windows or Linux. It's probably possible, but probably also super annoying. So if you want to use Final Cut Pro and that's a big thing for you, then yeah, you're going to have to get a Mac. And I think it's really smart to wait on the next chip, because the M1 chip is the very first one. It's the experimental one. That's the reason I got it. But the M2, answer text message here. The M2 I think is going to be a lot better. The compiler and the emulation environment is going to be way better. So I'm pretty excited about the M2. I don't know if I'm going to pony up the money. I'm a tad frugal, so I don't know if I'm going to pony up the money for an M2 when it comes out, but I did pony up for the M1, and it's been mostly awesome. It's worth the money. Nerd Shark says I would try a Hackintosh. I've never done the Hackintosh thing, though I probably should try it at least once, just so I can say I did Hackintosh and fell on my face, or I did Hackintosh and it was the most amazing thing on the planet. One of those two things will be what I say. And I do have some friends who've done Hackintosh stuff, and they're like, once I got it dialed in and got it good, it was amazing. So it's worth trying. I just haven't tried it myself yet. Where was I? Oh, that's right. We're going to do some work on this hot car project. So I've got my 4 CSVs here. And as people have pointed out online, I could do this with SQLite if I were a little bit better with SQLite, but I'm doing it with Go because I haven't written Go in a long time and I want to get better, keep my blade sharp, as it were. So we're going to do all this stuff in Go. And Go is perfect. It's perfectly reasonable. You can do this from the SQLite CLI, the command line interface, which is great. But you can also do it from Go, and Go's really fast. So cool. So for the very first thing I want to do here is, if you guys were watching during this last thing, it was kind of hokey. I basically read in a CSV file. We created a table with the very first car temperature CSV, inserted those timestamps into that table, and then used that as an index, and then read in all the subsequent ones to match. We're going to do the same thing, but I want to do it in one shot. Basically, I want to be able to run this process.go, have it create that database, create the table, run in the first set of data with those timestamps, and then use those timestamps as an index for the subsequent ones. That's the first thing I want to get out of the way. Once I get that out of the way and done, then we'll start talking about the Celsius conversion. I don't know exactly how I'm going to do that yet, but I might create another table, might create another database. I think it seems kind of silly to create another database, but let's help our friends outside the United States who want to use Celsius, or those in the scientific community who use Celsius also. So for the very first thing, we have DB name of test, and it creates a DB name. So let's change that. I want to change that to readings. Oops. And I'm still in that Mac mode where I'm hitting that button here instead of control. It's fine. So for the very first thing, I'm probably going to just comment out all of the things, and I'll put them back in. Oops. There we go. And then I'm just going to take all these and put them back into it as we go. So we have a DB name of readings. And what we want to do is check if readings works. Here's another thing I'm going to do. For the DB name, I just put in test. And then when I went in here to the data layer, I made a data layer and then just appended .db on the end of all of it. We're going to remove that. It's okay if we just name it something.db and we don't do all that silly appending. So I'm going to call this readings.db. And then we're going to do a little check here. So if error, OS stat, DB name, holy moly. Another thing I should point out, I'm using Tab 9 Pro right here. Tab 9 is an auto completion program. I do have the professional version, but you can get the free version, and it's awesome, mostly. I think anything that really jumps and gets in and starts suggesting things annoys me for the most part, but this one doesn't annoy me very much. So go here, tab9.com, code faster with AI completions. I used it on a big Python project I was working on a while ago, and I really liked it. It saved me a lot of time by doing auto completions of repetitive stuff I was doing. One could argue that if I'm doing a bunch of repetitive stuff, I'm not writing very good software, but it was just kind of the nature of the project. And this Tab 9 worked great. I decided to get the Pro version, but you can get the free version, and it works fairly well also. So anyway, that's when you start seeing things completed like this. That's from Tab 9. Oh, so if we'll catch an error, basically that's what this code's doing, is saying if this database name does not exist, which right now we're going to assume it doesn't, because it doesn't. We're going to say log print f database does not exist. So we know it doesn't exist, so we'll run really quick. Go run process.go. There we go. There's our log message. Now, I like to do this, and I'm sure a lot of you do also, but I like to just print F and log messages like crazy when I'm developing something, and I'll go back and pull them all out later. But I really like to just step by step say, database does not exist, and just talk to myself, because if I go back to this code in 6 months, I'm not going to have any idea what I was thinking, what I was doing, and I'll have to ramp up. So I'll put a lot of comments in code and a lot of log statements. So here it says database does not exist, we'll create one. And then here, we still have code for that, right? So let's copy that. There'll be a lot of copying and pasting in this little sprint we're doing here. So new database. And for those of you who aren't super familiar with Go, basically we're making a declaration here, new database. This is a new variable, and then we're saying comma error. So if something goes wrong with creating this, this error will be populated. We're doing colon equals, which means we're instantiating a brand new object. And then we're calling data layer create database with DB name. Now, as I said earlier, if I go into create database, right here we have DB name of string, and it creates a database with the .db on it. We're going to get rid of that. So let's walk through the code a little bit here. What I'm saying is we're going to create a new database object called newDB. And because it has the colon, it's creating a new one. It's instantiating brand new out of nothing. We're saying data layer create database with this DB name. This DB name will be readings.db. So in here, we're also doing another check, which is exactly like the check we did before, to see if it exists first before creating it. So we're doing that OS stat that says, do we have anything named readings.db here? If so, we're going to kick it out and not do anything. Whoops, hang we've got a fire call here. Okay. All right, so back to what I was saying here. I'm going to check the chat here. When you release your API, will it be on the public internet? Yes, it's on GitHub right now. Still. Okay. So it is on GitHub. I will find it here really quick and give out that. So the project I'm working on right now is Hot Car. And this is public, and this is the Go program to load in those CSVs and put them into a database. I also have Hot Car API, which isn't much of an API right now, but this is the one that it's an API that goes into a DigitalOcean app, and you can access this data. And I built that on a stream. Repo is private. Oh, you're right. You're absolutely right. Let me fix that really quick. So that should not be private. Change visibility, make public. Please type, nobody types this to confirm. And I'm not going to either. Copy and paste, there we go. Okay, now it's not private anymore. Now it's a public API. I don't think there's anything in there that shouldn't be in there. But I will dump this in the chat. There we go. Okay, and I will be right back in just a hot minute. All right, I'm back. Okay, so earlier Nerd Shark says, I know nothing of coding, but here to support the stream. Really appreciate that. And for that reason, I'm going to explain a little bit more about what I'm doing with this code. And right now I'm writing this in Golang. And I have a suggestion for you and anyone else who is watching me write Golang and thinks this might be kind of cool to learn. Here's a way you can learn it without even installing anything on your computer or anything else, and you can start writing Go. And here it is. I'll post this in the chat also. Check this out. So in here, you can say, you can just write Go code. Run. Hello, Jeremy. It's pretty cool. So you've got this interactive Go window, and you've got a bunch of stuff where this tour of Go tells you what to do in Go. Like it says, you know, put this in here and put this in here. And like this, it does a random number. My favorite number is, now here's something that's kind of interesting. Once you run this once, it'll always say 1. Because once it's seeded, that's it in the memory. But this is really cool. This is a good way to get your hands on Golang code without doing a thing. I mean, you could probably do this on your phone. I've never tried it, but you could do it on like a phone or an iPad. So you don't have to install or configure or do anything, and you can start writing Go. You know, like you can say number 1. Extra. Gotta remove that. There we go. Sum is 6. Which I did print line, which is improper. See, these are the kind of things you'll learn if you run this thing. There we go. So what I did is I created a new value of, and we called it just number 1 equals 1, and number 2 is 5, and then sum is percent value number 1 plus number 2. You can just sit here and play around. Who cares if you break it? Who cares if you lock it up? You just kind of play around with it, and it goes through a whole bunch of exercises. So if you want to get into Go programming, that's a great way to do it. I think once you start doing some Go programming and getting the hang of it, you'll probably get more curious and install it on your machine and start doing stuff, which would be awesome. It's one of my favorite languages for sure. So where in the heck was I? Oh, we're creating a new database. So we're going here and saying create database named readings.db if readings.db does not exist. And in create database, that where I'm passing this in, this is called a parameter. I'm passing in this DB name parameter that's readings.db. It's coming in here, and then they're checking it again. Does it exist? If it does, it says database exists. We're skipping the creation of it. If it doesn't exist, then we're going to create it. We'll just do an OS create. It creates a DB name, and it just creates this file with 0 bytes, nothing else to it, and then it returns true. If there was some kind of error with creating it, like there's permissions or something like that, then it will kick back an error, and it'll say false, didn't work, here's the error, here's why it didn't work, we couldn't create it for X reason. So that's what we're doing here, is just creating this new database. So we can actually run this as is. Let's run it really quick. New DB declared but not used. So if new DB log print line, we created it. And then I'll say else. else something went wrong. Go run process.go. It says database does not exist. We'll create one. We created it. And as we can see over here, we have data layer readings.db. Here it is, which is nothing. It's just a 0-byte file. It's nothing until we make it something, basically. So I'm going to readjust my window here so I can still see the chat. And this is one of the cool things about Pop! OS that I really like is I can actually organize my windows fairly well, so I can see notes and I can see the stream and make sure that everything is going the way it should. There we go. Perfecto. All right. So we're creating a database now. We're good to go. Now we need to create a table. So this is a blank database. We're going to delete it because it's nothing right now. And what I want to do is make this idempotent, which means we run this. No matter how many times we run this program, it's going to do the exact same thing. And so in order to do that, we want to make it so that if we run it, it's not going to duplicate data. It's not going to change things. We just want to run it and have it create a database and dump all the data in here. So that's what we're going to do. And I'm going to start putting in comments here. So like I said, in 6 months, I'm not going to know how this works. And for those of you who are newer to coding, you don't know how it works unless I explicitly say, this is what I'm thinking at the time. So I'll put create a new database. If the database now exists, and really, since we have this log failure here, so we're creating a new database or an error, if that error ends up being something, like if that database can't create it, throws back that error, it's going to do log fatal and it's going to close the program. But I have this else in here just in case that check doesn't work. I have never seen that with Go. I mean, usually when I go to log fatal, it crashes it and it spews out the notes. But you never know, right? I mean, that's what engineers do. They look both ways when crossing a one-way street. You never know. So we'll put that in here. And actually, we'll say, we'll change this to a printf, which is a formatted print. Say, we created %b for value, comma, DB name. Now when we run it, it'll say we created readings.db. And I'm just checking something here really quick. My apologies, this is kind of rude, but okay. So now it says we created readings.db. So delete that again. Now, this is where we're going to put a lot of code in. So now I want to create a table. I've created a database. Now I need to create a table. We do have a function to do that. Create table right here. However, I want to see if it exists first. Which, actually, now that I'm looking at my SQL statement, that's kind of redundant because it says create table if not exists. So let's just, let's create the table. And we're going to name this table reading here. So if new DB, we'll say data layer dot create table, and we'll create it with our new DB that we just established, right? Let's see if that works. Actually, no, because that's just the creation. We need to actually connect it, which is right here. So we're robbing some more code out of here. By the time we're done, all this code that I commented out should be gone. ideally. So database now exists. Since it exists, we can connect to it. And we're going to take out this because now we have the DB name as explicit. And we're saying DB connection. This DB connection we're going to use all over the place. So we're just going to create it right here and say DB connection SQLite 3 DB name. Something to note here, I'm using this SQLite. It's in the database layer. Make a note of this, github.com/mattn/GoSQLite3. This is the best GoSQLite library that I know of. And there's a few of them out there. There's quite a few of them out there. This one is the most compliant with everything I've ever needed to do with SQLite. So this is the one I use. So you just do go get, and then this URL, it installs it. It's great. It's definitely a very well-rounded, nice library that I haven't had any problems with, which, if you know me, I usually find something wrong with every library that I try at some point. Haven't found it yet with this one. This one is just perfect. So we'll put in here if the database now exists. Let's connect to it. So now we have our DB connection. Now we can call our friend over here, create table. Because we have a database connection. If it fails, it's going to log fatal and blowout. So now we can say data layer dot create table. And we're going to do that with dbcon. We're going to pass in our DB connection. Now, if we just run this like this, this should create the database and the table. Let's find out. So tonight's stream is being brought to you by ice water with lemon in it. Maybe a little too much lemon because it kind of made me cough there for a minute. All right, so we're going to go in here to Hotcar. Here's where I tried to make a Hotcar Celsius program earlier, and I'm like, I was actually going to create a whole new database, and I decided not to do that. So let's open up readings.db and see what's in it. Oh, we've got a reading table. So we've created a new database, and we've put a table in it. And this table looks like what we need, right? This is what we used on the last iteration of this, so we know that we need timestamp of text and all these floats. That's perfect. We'll minimize that. We will be back. So I'm going to do another, we're going to say created and an error. That way we can make sure that the table is created. That's what the whole purpose of this is. This is going to be a bool, because create table returns a bool and an error only if there's an error. It will return it. So basically it'll return true and nothing if it works, or false and an error if it didn't work. So it'll say false, didn't work, here's the error that I'm giving you. So that's the purpose of this. Created is our Boolean value. If created is true, then everything went great. Created is false, then we're going to display that error. And we'll, of course, do that with if error equals nil, log it, fatal, crash the program, and then we can find out why it wasn't able to create that table. But if created, table was created. And we'll do a little log print line there. Table is created. Perfect. All right, don't have any questions in chat, right? Okay, just checking to make sure everything still looks good and still working great. Okay, so now we've created it. So we've created a database, created a table. Now we need to do stuff with it. We can do something like check table created, but I don't think we really need to do that. So what's the next thing we can do here? If it's created, let's build a function here. So down here, I commented out a bunch of stuff. This is all the stuff that loads the CSV data into the table. And the way we did it last time was I loaded that first one, and then once the first one was good, then I commented it out and I refactored it and loaded in the subsequent ones. Let's clean that up a little bit and make it make a little bit more sense. The way I think we should do that is by creating another function. See, I'm trying not to repeat code, so I could repeat this each time for each of these 3 CSVs, but I don't want to do that. I don't want to repeat it over and over, so I'm going to create a function for that. We'll say func. We'll name this something like load CSV into DB. And we're going to need that DB connection here. And this is a SQL.db that we're going to pass into this. So we'll pass that DB connection in just like we do on the data layer. And we want to say, let's see, which CSV file. So we'll say CSV file, and that's a string. Because we're going to use this load CSV file, or this load CSV into DB, we're going to use this function on every one of these CSV files. So we're going to load in that car temperature one first. And we want a way to be able to say, this is the first one, do it a little bit different than the next 3. So actually, we'll put a bool in here. We'll call it first insert. Oh, first insert bool. There we go. And now we can call this each time for each of these CSVs. And then we'll rob some of this data out of here. So in our old stuff, we have this can go away. Deleting code is so fun. It's one of my favorite things on the planet. If new DB, do creator exists. Let's create a table. If table exists, okay, so we did all that. We've covered all of this. Now we need to get into this records. This is where we start to load in. We're going to do the read CSV file function and read this CSV into this records slice. So this is actually the remainder of our commented code. I'm happy about that. We're refactoring right now. So those of you who are new to coding, if you wonder what refactoring is, that's exactly what we're doing. We're changing the method in which we accomplish something. So if we have records equals read CSV file outside temperature.csv, this will all stuff this in here. What we're going to do, the very first thing we're going to change is read CSV file. We're going to make that CSV file. Because we want to be able to specify new CSV files. If we leave this hard-coded, obviously, oops, I don't know why. There we go. If we leave this hard-coded like this, then every time we call load CSV into DB, it's always going to call outside temperature.csv. We want to be able to change that. We want to parameterize it. So we'll say CSV file. Now, whatever CSV file we pass in here, it's going to read. And then we don't have to rewrite any of this code that we wrote last time, right? So we did this stuff with the timestamp where we shaved off the seconds of the timestamp. And then we rounded the timestamp. So we say if it's over 30 seconds, we're going to say it's at 30 seconds. If it's under 30 seconds, we're going to say it's at 00. That way to kind of line that all up. All this code is still valid and still good. In fact, all of it's good until we get to right here. This is where things are going to have to change in the insert. And as you can see, we've got first insert, which we commented that out before. We'll comment it out again. So this was our first insert. Now the difference between the first insert and the other inserts is the very first insert will insert an entire record. It will say timestamp with a value. And then that timestamp becomes our index. So we only want to do the first insert once. And that's what we put this little bool up here for. This little bool, first insert. If it's the first insert, so we'll just say if first insert, put a comment. If this is the first insert, we will insert timestamps and data. Perfect. So when I come back in 6 months, I'll know what the heck first insert means. And then we're just going to grab these. Cut that out. If it's the first insert, insert stuff. Probably just log fatal on this one. Actually, no, we'll just say could not insert. Actually, could not insert's better. So we don't necessarily need to kill the whole program. We can find out why we're not inserting. So if this is the first insert, we'll insert timestamps and data. So we'll do first insert. We'll use that DB connection that we declared way up here somewhere. Oh yeah, we pass it in to load CSV into DB. Timestamp and value. And this value should be first insert. That value will be the car temperature. So if it was successful, we'll log it. We'll just not if it's not nil, if it's just if result. And actually, I might get rid of this later, but so if it's a first insert, we'll dump all these values in here. If it's not the first insert, then we're going to snag this part, and I'll explain it. I don't want to be one of those people that writes code and just does it at like 1,000,000 miles an hour and doesn't explain anything, because the whole point of this is we're going to try to learn and get some feedback on what I'm doing. So if the first insert, if it is the first insert and we've specified, yes, this is our first insert, then we will do the first insert, which will do a different kind of insert. We'll show that really quick here. First insert says insert into reading timestamp and car temperature, and it puts both those things in. If it's an insert data, then we're still passing in that timestamp, but we're saying update the existing record where the timestamp is equal to X. So as we go through all of those CSV files like this one, it'll say where the timestamp is this, put in this. So there's going to be some finessing here before this works properly. But, and okay, there's an issue right there that I can see. but it's fine. Outside temperature is our table name, right? So if it's not the first insert, then it's got to be one of those other three. We got to find a way to parameterize this table, because otherwise it's always going to insert everything in the outside temperature every single time. So what I could do, since I have these CSVs named exactly like the table names, that car humidity, car temperature, blah, 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 then we can extract that table name from that file name, which I believe I'm passing in. Am I passing it in? Yeah, CSV file. So I can just say CSV file. We'll grab that. Now what we need to do to CSV file is shave the .csv from the end of it. So I'll show you how we can do that. We can do it the same way we did, where is it? Right here. You see how on the timestamp I shaved 2 characters off of that? Let's look at how we did that. We did that with a slice. So we're basically saying timestamp and then the length of the timestamp, however many characters it is, -2. So in that case, if we had a timestamp with, you know, a 2-3 on the end of it, we would round that down to a 0-0. That's what we're going to do here. We're just going to shave that off of there. So insert data, CSV file, and I'll copy this up here for a reference so people can see what I'm doing. We're going to say CSV file, and then we're going to make a slice of that CSV file without the last 4 characters. So we're going to say length of CSV file, however many it is, but we're going to subtract 4 from it. Now we should be able to say car temperature.csv. We're going to shave 1, 2, 3, 4 characters off, so it should just be car temperature. This should work. I always say should, because sometimes it doesn't. Okay, nothing in the chat yet, so we'll remove that little reference, and then I'm going to put some comments in here so that this makes a little bit more sense. So if it's the first insert, we'll insert timestamps and data. And actually, you know there's an error, but we'll put if it was good. And I think my camera just died again. So I've got the back of my camera flipped up now so I can see when it dies and goes black, because it's been doing that. Usually when it's hot. It's a little warm in here. Camera doesn't feel warm, but for some reason it just quit. So now it's back. All right, if it was good, we'll print success. And this is first insert was done. Let's populate those records. There we go. So that was a long, this is actually kind of a long method. As I'm looking at it, it's a pretty long, pretty fat method. Further refactoring, I might reduce this a little bit. But let's go ahead and do this load CSV into DB up here. When our if table is created, this is where the good stuff happens. So we'll say load CSV into DB. We'll use dbcon as our connection. CSV file for a string. We'll put in, which one was the very first one? Car temperature .csv. We'll pass this in as a string. And then for first insert, we want to say true. So now, when I run this, we'll test it right here. Now if I run this, it should create a new database, create the table, and load the very first set of records, which will be a timestamp and a temperature of the car. Let's find out. Unable to read input file. No such file or directory. Yep, that's possible. File path string. Unable to read input. File path. Okay. Parse CSV, unable to open it. So maybe it's like I need to put a little dot in there or something. It still created the database, as you can see here. But we're going to delete that because we don't want it anymore. And then we're going to try to run this again. Nope. Unable to read input file .car temperature CSV. Oh, that's right. It's in the CSVs folder. All right. Check my phone really quick here. Okay. Just wanted to make sure that fire call was going well and everybody was there. All right. So since I put it in the CSVs folder, I think I need to run something like this. Nope, still unable to read it. File handling can be a little strange sometimes. If you run this on Windows, there we go. Now it's spitting out data. If you run this on Windows, it's going to be a little bit different. Just a heads up, and that might be a refactoring that I do in the future is I'll check for Windows and do it a little different for Windows. All right, and while this thing is inserting, I'm going to do a couple of tech checks. Looks like all my streams are going well. I still have a camera. Screen seems to be pretty good. Oh, and we actually inserted all the data. And checking something here really quick, see what we look like on Twitch. We look pretty good on Twitch. Boy, howdy. I love doing these live streams. Like earlier, you know, we did the troubleshooting on here. Sometimes people call me out on the code that I'm doing and say, hey, why don't you do this? I also love that. So I'm going to be doing a lot of this Twitch. Actually, this is a really good time here to show this. Raspberry Pi 400. So everybody who retweets that tweet and follows me on Twitch, when I get 500 followers, I'm going to give out one of these. Not this one, but a brand new one in a box. Sent to your house in the United States. This thing is one of the coolest things in the world. Actually, I'm going to plug in this exact one and do a stream from it. Now, I know it won't run OBS or anything like that. So what I'll probably do is RDP into it, and then we'll do some cool Raspberry Pi stuff. But this is a cool little device. It's great for kids. It's great for beginners. It's great for non-beginners. It's great for, check this out. I don't know if you can see that, but that's a GPIO port on the back of this thing. So you can plug sensors right into it directly and write code and plug it in, and it's awesome. And I'm going to send it to one of the people who retweet and follow me here on Twitch. As soon as I hit 500 followers, all you got to do is retweet that tweet. You can even delete your retweet and retweet it again if you want. Either one. But I'm going to give it away. I'm going to use some kind of app. My wife uses an app for giveaways, so I'll probably use that app, and we'll do it live on a stream so you can see whether you are the winner or not. Now, enough babbling. Let's go back to what I was doing here. If this worked, which it says success, which indicates success, right? If this works, then this readings DB should have a table, Should have a list of timestamps, and it should have the car temperature in it. And I'm probably going to have to reopen the database. There it is. Let's browse the data. Ta-da! There we go. So I've taken all the timestamps out of car temperature.csv, and we've loaded in the actual car temperature and the timestamp. So now every insert that goes after this isn't actually an insert, it's an update, so I should probably rename that. But now it's going to go through and it's going to say insert car humidity where timestamp is whatever out of that CSV file. But now we're doing it in a lot more elegant and smooth way. Because we're just going to copy and we'll do car humidity .csv, and this true or false is it a first insert? Well, this is not the first insert, so we're going to set it to false. We're going to say outside temperature CSV. This is also false. And then outside humidity. This might take a while. So, better change that to false. So now it should go through. I'm going to delete this database again. Again, we're going for item potency. So we want this to just be a one shot. We run it, it creates everything, it makes it great. So that's what we're shooting for here. So now it's going to create a new database, create a new table. It's going to insert the car temperature, and that's going to be the first insert. So it will insert a timestamp and a value. And then for these three, it's going to correspond the value, whatever it is, car humidity, outside temperature, outside humidity. It's going to correspond that to a timestamp that was inserted in that first insert. So what I'm going to do is run this, and then I'm going to run out of the room really quick. So we'll both find out if it works in a minute. I'm back. Did it work? No, it did not work. I'm shocked. Failed to prepare SQL statement on each of those. So we know that this probably happened during one of those subsequent inserts. So let's find out why. Let's delete our readings DB. Actually, let's check readings DB. Just to kind of see what it looks like, see how far we got. And it looks like we didn't get any of the subsequent values in, just that first set of values. So we'll close it. We'll delete it. And we're going to find out why. So load CSV into DB. Scroll down here. If insert was done, let's populate those records. First insert. I'm going to call this update data because it's confusing to be called insert data for one. So Let's refactor this to update data, because we're actually running an update statement. And that's where we're having the problem. So we have SQLDB that's passed in. Column name is string. And it's having a problem with this prepare right here, because with the error we're getting is failed to prepare SQL statement. So let's print the error on that also, and maybe we can get even more detail. So we'll say car temp error equals this. Error declared but not used. If error is nil, we'll make that thing go fatal. Because this thing, I believe, is returning this. Load CSV into oh, that's right. We're not returning an error, so we don't have to do all this. Never mind. This is truly coding on the go right here. We can spit out the error down here. If error is not nil, instead of could not insert, let's log the actual error. And the music just got weird, right? So we'll just dump the error. We'll log fatal. So it kills the app. And let's dig a little deeper into this error and what it means. Success, 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 all the way down until that first insert, then it should spit out and die, ideally. Unfortunately, we have to do that first insert with all of those in there. You can see the journal running right here, so you know it's still accessing the database. Isn't this fun? Thank you, all 20 or so people who are watching who are not heckling me right now. Why does it still say could not insert? Oh, because I need to do it down here too. Herp derp. It's probably my favorite thing to say. Herp derp. I really want people watching to know that, you know, I'm not preparing like a smoke and mirrors show for you here. And I want people who are watching to know that mistakes happen when you're programming, and that's part of programming. Like I said, I've been doing this 19 years. Sometimes you'll build something and you'll be like super confident, yes, this is absolutely going to work. This is how it's going to work. And it just all blows up. And then you're like, oh, I forgot this small thing. Since I was out of the Go programming, I didn't write a line of Go for months. I've got to jump back into this. And that's why I'm doing this with Go, is kind of force myself to jump back into Go and keep sharp with it. Let's kick up the pace and let's play some rock from Harris Heller's list here. There we go. Failed to prepare SQL statement near dot. Dot. How in the heck did a dot get in there? Into here. Let's log what the column name is. So here's something you can do. You can do log fatal column name. And this way I can just see what I put in for a column name, and it's going to quit the minute I call this. Like as soon as I call it, it's going to log fatal and shut the whole program down, but at least I can see what the column name is that I'm passing in, because I think that's where my problem is. It's a little bit clear. Delete that readings.db. Let's run it again. While it's running, I would like to take the time to thank everybody who's gone on this stream today. Really appreciate it. So I'm getting a lot of followers on stream, on Twitter, who are watching my stuff, and I get a lot of emails, and a lot more people watch it after the fact. So those of you who are watching it live, I really appreciate. It's pretty cool. You're getting the first glimpse. Most people tend to watch my streams after they're published for whatever reason on YouTube and Twitch. So thank you for watching it later on your own time. I'm having a lot of fun doing this live coding. What it does is it makes me a better presenter. Oh, see, I got that CSVs in there. I got to remove that. I'll probably just do a string replace and remove that. But so what this does when I'm streaming live like this, somewhat unprepared, just opening up the ID and going, what it's doing is it's making me a better presenter, which is technically one of the things that I do for a living. So I'm a developer evangelist for Pluralsight, and one of the things I do is presentations. So the better I get at presenting and the better I get at live coding, the better I can do my job and the better I can teach people. So that's one of the reasons I do this. Another reason I do it is because I learn as much from the people watching as I'm teaching, if I'm being completely honest. And so a lot of that feedback that comes in via email, via the chat room, whatever, I'm learning from it. So, you know, never stop learning. That's the little tagline that I put on jeremymorgan.com forever, is just never stop learning. And you all are helping me to continue learning. So I think we can do a strings replace on this. Let's find out together. Strings replace. I think I can just take this. I don't know for sure if I can do this, but I'm going to try. Because I want to pass this thing in. Oops. Without that dot slash CSVS slash. Let's see if it's going to let me do this. I don't know if it's going to let me do this. It doesn't look like it. Probably not. So I'm probably going to have to extract this out a little bit. And we're going to say table name equals, CSV file. It'll let me do it that way, right? Probably not. It really doesn't like that, it looks like. So let's do a little preparation of this beforehand. So we're going to say table name. We're going to create a new one. So in Go, if you say table name equals blah, blah, that's an assignment. And that assignment assumes that table name has been created. If table name has not been created, you just put that little colon in there. And that means we'll create a new value of table name with this. And what I'm going to do is rip this whole thing out of here. And this is just for my understanding. So table name should be strings replace, blah, blah, blah. Let's do a log fatal before we start. too few arguments. There we go. All right. Now let me explain this mess that almost looks like regex that I just spewed onto the screen. What we're saying is our table name is, now our CSV file, the CSV file string right here that we're passing into this function is ./CSVs/car humidity, because we're saying it's in the CSV folder and we wanted to be really explicit about where that is. So what I'm doing is we'll start at the very beginning. Right here, we're saying CSV file, and then we're taking a slice of it. Go slices is one of the coolest things about the Go language. You can take and slice, like literally slice the data, which is why they're called slices, right? But it's far more complicated than that. But you can slice this data and you can say, out of CSV file, I would like the length of CSV file, whatever that is, -4. So that gets rid of that .csv extension. And then we'll pass that. So this is the name of the CSV file, which would be car temperature .csv minus the .csv. So now it's car temperature. And then we're going to do a strings replace, and we're going to replace this right here with nothing. And we're going to do that with, we'll set the length of the CSV file, so we'll make sure we're taking that entire name and just ripping that CSVs out of it. This should work. I know I said this a few minutes ago and it didn't, but it's going to work. So I think I did a log fatal up here that I got to get rid of. There we go. Now I think we can run this and it'll work. Fingers crossed. We know this first part's going to work. It's going to spew through those. But then we should have 3 more data inserts that come out of this. So we'll find out together if this is going to work. I think it is. I'm pretty sure. I'm going to sit here and sip my ice water. I'm going to throw out another promo here since we're waiting. Real lemon. Right here. True lemon. So this is a lemon packet with like dehydrated shredded lemons in it. Now obviously they're not paying me to promote this, but I'm just promoting it. These are the little lemon packets that I put in my ice water. And it tastes like an actual real lemon because all it is crystallized lemons. So you just tear open the little packet, dump it in ice water, and you have lemon water, which is what I'm drinking tonight. I know, kind of boring. But I love this True Lemon stuff. You can get it on Amazon. You can get it in a lot of stores. They also have True Lime, True Orange, True... well, those are the 3 that I know of. And this little powder, you just dump it in there, and all of a sudden it tastes like there's a lemon slice in your water. It's delicious. It's amazing. I'm looking at the inserts here, and I can see I'm inserting just a pile of values. So I'm pretty stoked about that. We just hit the hour mark in the stream, which of course, as you know, is the 3rd stream that I had to start up. But we just hit the hour mark on this stream. Streaming from a 10-year-old Mac Mini. I don't know if this thing's going to choke. I don't know. But it seems to be streaming in 720 pretty well. So I might jump on this machine and do streams again. I don't know yet. You might be asking, why in the heck would you use this 10-year-old slow Mac Mini when you have a Digital Storm workstation and an M1 Mac Mini? Which is a fantastic question. Except that right now this thing actually works and does everything I want it to do. It has the chat, it has the sound. My M1 does not have line-in sound. Can't get it to work. So I don't have the little music that's playing in the background on the M1. On my Digital Storm workstation in Linux, I don't have the chat. The chat window doesn't work. So there's all these little things that don't work. The Windows, when I stream from Windows, that actually works pretty great on the Digital Storm machine. And I'm going to be doing that Monday when I'm going to show you how to write a Blazor application that does facial recognition. But the reason I'm streaming from this is because I wanted to stream from Pop! OS. I don't have Pop! OS on any other machine that I can stream from. I've never tried streaming from my laptop, but so I basically wanted to show off streaming from a 10-year-old machine for those who are thinking about doing something similar to that. Looks like everything worked. I don't see any errors. So let's find out. I have a good feeling about this. Look at that. 520K. There we go. All right. So we have now the timestamp, car humidity, car temperature, outside humidity, and outside temperature. Now these, as you can see, they didn't quite match up. That'll be another refactoring stream, I'm sure. I will try to see if I can extract these values somehow, because I don't know if they're sensor failures. I haven't dug into it enough. I mean, let's dig into it right now. We're here. So right here, we'll copy this at June 27th, 8:14. We don't have any outside humidity or temperature. So let's just look and see outside temperature, CSV, Control F, and let's see what we have here. We don't have anything around 2014. Oh, as we can see, that data is missing because we just didn't get a reading at 2014. So what I could probably do is round up the 2013 value. But yeah, that was just kind of a skip, and that's kind of the way I set this up at 30-second increments, so I just need to kind of adjust those increments, right? Because this was 30 seconds, but, well, they were taken at 30-second intervals, but we have clock drift and all kinds of things. So we took a sample at 1320. We've got another, the next sample was 1353, and then we didn't have any other sample for a minute, or 2 minutes, I'm sorry, 2 minutes until this. So I'm gonna have to massage this data a little bit, but I don't know how much massaging I'll actually do with it, because I don't want it to be too inaccurate. But anyway, this data looks good. This is what we wanted to accomplish tonight. Is we've got this a little bit cleaned up now to where you run the Go app and it spews out the data into the database. Celsius is the next question. So what I could do is call this reading F for Fahrenheit, and then we'll create another table for Celsius. There's a couple ways we could do this. Let's sit and think about it a little bit here. Load up my chat for if anyone wants to call me out on my thinking. We can create another entirely new database. So the way I have this set up here, go all the way to the top. At the very beginning, we have readings.db. We could name this Fahrenheit.db, run these things, and then create Celsius.db. Two separate databases, one Fahrenheit, one Celsius. That seems like crap to me. Or we could create another table that's a Celsius table, and we could have a Fahrenheit table and a Celsius table. Now the problem with that is we'll have two separate tables and we'll have duplicated data. So we'll have some humidity readings that will be the same in both tables. And Madam, and you're going to have to tell me how to pronounce your username, because it could be Madam, it could be Madome, it could be I'm not sure how to pronounce it, and I don't want to be a jerk. Madam says, can we store Celsius in the same table as Fahrenheit? I think that's the smartest move. Madame, like domain object model. So Madome. Okay, awesome, thank you. Madame, like domain object model. Sweet. Madame says, can we store Celsius in the same table as Fahrenheit? I do think that's the smartest way. And the reason is, so if we create two different databases, readings.db becomes Fahrenheit.db, and then we have Celsius.db. That's two separate databases that we would have to connect or something silly. And even two separate tables is duplicative because we'll have humidity values stored in each one. I do think that creating another, putting them together, creating them in the same table, I think makes sense. So if you want Celsius, you'll pull Celsius. If you want Fahrenheit, you'll pull Fahrenheit. So let's refactor. So now we got to go all the way back to the beginning when we create the table. Where did we do that? In data layer, we did create table. So right here, we'll have timestamp. We're going to keep the timestamp. Obviously, the timestamp doesn't change with the measurement. And then we'll have car humidity. And I could do, so car humidity obviously isn't going to change. It's a percentage. Maybe we could do car temperature F and car temperature C. How does that sound to everybody? Let's see, car temperature, or oops, not humidity. Car temperature Fahrenheit. Celsius. And then outside temperature, I hope I'm spelling this right. In fact, to avoid embarrassment, I'm going to Google it really quick and make sure that I'm spelling this right. Okay, yeah, I'm spelling it right. Perfect. So we'll have outside temperature Fahrenheit. Outside temperature Celsius. This is probably the smartest way to do it that I can think of without duplicating data, without creating a gap between two databases or two tables or two databases, which two databases is the worst gap we could create. Two tables is also a significant gap, so I think this is the best way to do it. Thank you, Madame. Suggesting, so create table if not exists. We're going to create all this. First, let's just make sure that this works. So I'm going to delete the readings DB. I'm going to jump back into process.go, and we're just going to create that very first table and make sure that that works. No column called car temperature. The joys of refactoring. This is it. This is one of the best reasons to use an IDE, because sometimes an IDE calls this out. So for that first insert, we need to do car temperature Fahrenheit instead of car temperature. Not to mention that CSV thing that I did earlier, where I'm taking the name of the CSV. That's not going to work either. Just FYI. So this refactoring is gonna have a cost for sure, but it's worth it to get the kind of data that we want to get out of this thing. And we'll just make this thing better. So now we get reading, and check that out. And I already have an idea where we could probably just append Fahrenheit and Celsius to the end of the table name and probably get what we need to get. Oh, but I don't have a outside temperature Celsius. I forgot to add that in. So let's do that. Oops. So we'll go into our data layer. Oh, I did ask for outside temperature Celsius, but I don't see it. So we have car humidity, temperature Fahrenheit, outside humidity, outside temperature. Yeah, that was a little strange. So as I'm looking at this, I can see what I did wrong. Now this should be the right table create. Go run. We'll run it again. So thank you for spending your Saturday night with me. I guess if you're watching now, that means you're like me, and this is the coolest thing you could find to do on a Saturday night. And that's awesome, and I appreciate it. This is the coolest thing I could find to do tonight. And these are what my wild Saturday nights are like. Playing with tech and code and learning and doing stuff. All right, so we got success for all those. Let's open this up again. So you do have to reopen this database most of the time. And there we go. We've got car temperature Fahrenheit, car temperature Celsius, etc. So now I'm thinking about this for a minute. How I can do this. I think I'm going to put another parameter on that update. So with this first insert, it doesn't matter because the first insert, of course, we're just inserting timestamps and then that car temperature value. We've changed that, right? So if we browse, we've changed that to Fahrenheit. So it's car temperature Fahrenheit has been inserted. And then for subsequent ones, we just need to drop in the humidity and then the values. I would like to do it. So let's see if I can explain this here. So in the subsequent ones, the very first one, we're inserting this timestamp. We're dropping it in there. We're dropping in car temperature Fahrenheit. What I would like to do is also insert Celsius with the same pass. And this goes into, you know, algorithms and things like that, big O notation, all that kind of stuff. Where, you know, I don't want to loop through every single time. Like I don't want to loop through all these values and install or insert humidity and then Fahrenheit and then Celsius and then out, blah, blah, blah. I'm going to try to compact these into as few cycles as I can. And I'm going to have to do a cycle for every one of the files. There's no way to get around that right now with the current setup that we have. So I want to insert car temperature Celsius in that same insert statement. Then I'm going to have to pull in humidity. So there's going to be a minimum, I think, of 4 actions no matter what. But I want to keep it 4 actions and not 8 actions or 6. Right? So if I have one action that drops in this Fahrenheit and then I create another one that does Celsius and then another one, we could have a total of 6, but I'm going to try to keep this to 4. So let's do another refactor. And our refactor here, load CSV, car temperature.csv. We can still use this name in there. So we'll go into first insert. We can still take this value that's passed in. Do we pass in a value? Oh no, this is hard coded. So we'll change that. And we'll say, let's see, color. We're going to use the same value. All we have to do is use this this value and convert it to Fahrenheit for the second value. So we're going to say Fahrenheit equals value. So we know it's Fahrenheit in the CSV. So as we're doing this, prepare, use comma, exact timestamp value. And we're going to use this. Okay, so this will work as is, right? We're just saying Fahrenheit equals blah, 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 car temperature Fahrenheit. But we're going to add on car temperature Celsius. And now we have to add on Celsius. And since I don't know it off the top of my head, I'm going to have to find out how to convert Fahrenheit to Celsius. Let's Google it, shall we? Convert Fahrenheit to Celsius. There's got to be some example here I can find. There it is. Look at that. I don't even really have to think about it. Minus 32 times 5 divided by 9. Ironically, the sensors that I used Celsius originally, and I converted them into Fahrenheit because that's what we use here, not because it's better. So now I'm just doing the reverse of that for our Celsius value. So now we should be able to insert temperature Fahrenheit, temperature Celsius as a part of our first insert. So let's find out how that goes. And then we're going to do that another time. Yeah, we'll think about that when we get there. So I deleted the database. Now we're going to run it again. And we're going to find out how this goes. I'll jump out really quick and then I'll be back and we'll look at our progress. All right, looks like we've got success. Let's see what success looks like. Yeah. So there we go. We've got car temperature Fahrenheit, car temperature Celsius. My brain doesn't really process Celsius really well, so I think it looks right. I know that 0 is frozen, 100 is boiling water, so these values look pretty good. So we are going to have to, so we're able to insert those in one shot. The next shot will be the car humidity, the outside humidity, then Fahrenheit. So it's going to take about the same amount of time, really. I mean, that little conversion that we're doing here, I don't think this is going to add very much time to our inserts. I hope not. But let us do that in our update data. So one thing I've noticed, we are going to have to specify whether this is a... So right now this is pretty generic. It just updates reading and it sets column name to whatever, where timestamp is whatever. We're going to have to get a little more explicit, and we're going to have to specify whether it's temperature or not. So we'll say temperature bool. And then we'll change the SQL based on that. This should be a really small change. Let me think about how to do this. So update reading, SQL. We'll just make it blank for now. And then we'll say if it's a temperature, then we'll dump this stuff that I converted here. And our update reading SQL is going to look a little different if it's a temperature. So update reading set, and have our column name. So column name plus Fahrenheit equals the Fahrenheit value. Right, so equals set column name plus Fahrenheit. Yeah, I might have to play with this update a little bit here. Because I'm not sure in SQL if you can do multiple updates in one shot. So for now, we're going to have to drop this whole exec in here. Update reading set. Well, let's look it up, see if we can do multiple updates. So I don't know SQLite enough to know if you can do this. Yep, you can do comma. Okay, cool. So update reading set column name plus Fahrenheit equals blah, blah, blah. And then we'll do another one of these. Column name plus Celsius. Plus equals question mark. How does that look? My IDE doesn't like it because it says update reading declared but not used. Don't worry, it will be. Right here. Actually, I'll probably pull these down. Okay, now I'm thinking about it, I can't really do that, can I? So we are going to have to pull these into scope. Unfortunately, I didn't want to duplicate these two things, but for now I'm going to. So exec. Now we're setting two different values. So we're going to set Fahrenheit first, Celsius, and then timestamp. So if it's a temperature, we'll drop in Fahrenheit and Celsius right here. Else, we're just going to drop in the value, which is what we had before. I don't even remember what that one was. Okay. Else, I'll just take this whole thing. And I might, if I really sit and think about it, I could probably find a way to not do this, but actually I think I can extract the statement exec out of it. No, statement exec's different. So update reading, set column name. Remove this. There we go. So if it's a temperature, then we're going to drop in two values, Fahrenheit and Celsius, column name plus. Else, we're going to just drop in, and this is if it's a humidity. So I'll even put this in here. If it's temperature, if it's humidity. This, I think, should work. Said this a few times. So load CSV is going to be a little different, right? Because update data now needs temperature. I should be able to put false here. So first insert. Oh, that's right. I'm going to have to switch it. So sometimes it's going to be false, sometimes it's not. So this is going to have to, we're going to have to bubble this up to this one. Is it a first insert? And is it temperature? And then we can just drop in temperature in here. And now we'll pass it into the original calling if it's a temperature. So load CSV. Yeah, it's temperature, even though it doesn't actually matter for the first insert. For the second insert, humidity, we're going to say false, false. And now for outside temperature, yes, this is a temperature, so we're going to say false, true. And then last is outside humidity. All right, for those following along, I'm calling load CSV and saying use this DB connection, use car temperature, true that it's the first insert, right? So we're saying this, yes, this is a first insert, so please create the initial records. And then yes, it's a temperature, so you're also going to need to insert the temperature, which really doesn't matter because in that first insert, we're doing the temperature anyway. But for now, this is simpler. Then the next one, we're going to say this is humidity. No, it's not the first insert. No, it's not a temperature. So just drop the value into car humidity column. for the second one, or third one. This one says outside temperature. No, it's not the first insert, but yes, it's a temperature. So please insert those two values. And then for the last one, outside humidity. No, it's not the first insert. No, it's not a temperature. Cross our fingers on this one. We're starting to get some more complexity here. We're starting to get more complex for sure. Which is fine, but it could be a little scary because the more we add on to this, the more stuff that can go wrong, obviously. Keep going. Wow, there's 15 people watching on Twitch. That is awesome. All right. Jumping back in. Failed to prepare our SQL statement. Near where? So that was probably right in the very beginning. Car humidity. So if we're looking at this, we know that we're going to pass this update. We're going to send in a value. So let's just look at the very first call and we'll focus on that. Actually, the first call worked. Like if we look at this, open the database. Boom here. First one worked, and it shows Celsius and Fahrenheit. So the first one works. It's the subsequent one that's having the issue. So we know this one works. And that's great. This is the one that we need to focus on, where we say car humidity. No, it's not the first. No, it's not a temperature. So as it's passed in here, we have the value. Let's see, first insert. It's not a first insert, so we're going to need to figure out what's going on with this update right here. And this is just a string, right? So we can do a log fatal. And we'll do update reading SQL. We'll delete this and run it again. And then we can take that SQL and we'll run it against our database that I just deleted. But that's all right. This is going to work. I have faith. If I didn't have blind faith, I wouldn't have any faith at all, right? This is going to work. Just got to massage it a little bit. A little fine tuning. Near where? Failed to prepare SQL statement. So it didn't even log fatal on me, did it? I wanted it to log fatal so it would show me where it died. Okay, let me check something here really quick. Okay. So let's figure this out. Now this is happening before, like, failed to prepare SQL statement. This is happening before this even is reached here, line 77. So near where timestamp equals. So question mark, column question mark, where. Failed to prepare SQL statement. So I'm not sure why it doesn't kill it right here. But what we can do is we can do log, print line, update reading SQL. We should be able to dump it there right before it dies. And this will tell us a little bit more about what's going on, hopefully. No, I keep promising, and I haven't done this in months, but I keep promising 8-bit video games. One of the things I did right before I jumped on stream was installed an emulator on this machine to see if it would play, and the sound is terrible. Sound doesn't work, but I have my controller here. And it's an 8-bit NES emulator. And we're dying before... So what in the heck? It's failed to prepare SQL statement, so it's just dying without displaying this at all. So I'm wondering if it's dying. I'm gonna test this. I'm gonna test something really quick. So I'm gonna do that first insert and see if it's actually dying in the first insert. I don't think it is, but I just want to see where this thing's dying. This is a little odd. I feel like we've watched this together more than a few times. That maybe I shouldn't just print out success. We should make it do some kind of light show or something. Some animated gopher. Okay. So we got nothing but success. And if we look at this, let's open it up again. Well, boy howdy, it's working on that very first insert. So it is happening in a secondary insert, but I'm not able to catch it for whatever reason. So it's got to be early in the method. So this is load CSV into DB down here. This does all these conversions, could not convert value, etc. Log fatal error. It's probably coming from right here. It's doing this update, and the result error is coming back. So update data, which is where we are here. How are we catching this? If the secondary one, let's see, this is one of our subsequent inputs, right? This is humidity. So if it's humidity, that's what my problem is. I'm trying to log this update reading SQL in the wrong spot because this isn't temperature, this is humidity. So here is where I need to. This right here, line 98 now, is where the error is happening. So that's what I was doing wrong. I was trying to log the update reading SQL from a temperature update. It's not a temperature update. It's right here. So this should tell us what I'm doing wrong with my update statement. And let me look at it really quick. Update set column name equals where timestamp equals. This column name probably needs massaging again, because didn't we do something with a column name? Or no, we're massaging it before it gets put in. So I'm going to log it though, just to see. Print line. We're going to do printf. Column is %v for value, comma, column name. There's an extra comma before the where, says the real Mitchell. Awesome. Because we're only updating one value. So thank you, the real Mitchell, for saving me another cycle here. I didn't even notice that. We'll just run it like this anyway, just in case something breaks. I don't think it's going to. I think the real Mitchell is absolutely right here. All right. The moment of truth is coming soon here. And thank you, the real Mitchell, for joining in the chat and for watching the stream. My silly Golang adventures. We've been on here a little while now. It's almost feature complete with the stuff that I wanted to complete today anyway. Oh, and what I was saying earlier is I downloaded an 8-bit NES emulator for this that I might try playing on here. But it seems like this... oh, look at that, inserts. We didn't get inserts before, so rock and roll. We're moving. We're going somewhere. But I don't know that this old ancient computer, while I'm streaming, is going to be able to run an 8-bit video game. But I'm going to test it before I get off the stream. And I might come back on later. You know, my family's going to be home here pretty soon, and I want to spend some time with them. But like after my wife falls asleep and my kids grab their devices and go to their rooms, I'm going to be all by myself again. I might come down here and play some 8-bit video games and stream. Or I might go to bed. I don't know. But if you know me, you know I like to prioritize my time appropriately. That's why I decided to stream right now. The house is empty. I'm all by myself. So I'm just going to sit here and geek out and do geek stuff and spend time with you folks, which is enjoyable. And then when my wife and children get back home, I'll spend some time with them. Sometimes I'm still surprised that my teenage children like to hang out with us. Because I didn't like to hang out with my parents much when I was a kid. I was a jerk, I guess. And our kids actually like to hang out with us, so... And the real Mitchell, is the real hero, found that comma. So now we have half of our data that we need. We've got the car humidity, we've got the car temperature in Fahrenheit, and the car temperature in Celsius. So now we just need these other three. I'll uncomment those, and we'll run this again. Up here, where did I commented out because I wanted to kill it. Okay. Delete. All right. Moment of truth. This is the culmination of this entire over an hour stream, if this works. And Real Mitchell says, what about doing this with batch inserts for performance? Absolutely. I think I could actually put all of this into a single query that would do a batch insert. That would probably be better. It might even be faster to combine all 4 of these CSVs into one CSV and then load that CSV in through the CLI. There's some different ways, so that's a good idea for a stream that I could do in the future is maybe for a stream we'll do some benchmarking and we'll time this way that I've done where I'm parsing all these CSVs and inserting them. And then we could try one big giant SQL statement, see if that's faster. We could combine all 4 CSVs into one CSV and insert that and just time all of them and see which one's faster. I'm going to be doing a lot of SQLite and Go stuff in the future, and we'll learn together. And Real Mitchell says, do you write Go for work too? Not really anymore. So I just completed a course on the Go standard library, and I was doing some Go for work previously, but right now I'm a developer evangelist at Pluralsight. Pretty much the only Go code that I write is for fun, unfortunately, the last 6 months or so, which is why I chose Go for this, is because I want to keep my skills sharp and keep into Go. But I'm building a website for my wife who has a real estate company, and I think I'm going to use Go for that. I'm still doing that initial analysis to see if I want to use like .NET platform stuff or Go, and I might do a Go web API for her website because I want to stay in the Go game. But hello, Ringo Mar. Thank you for joining. So yeah, to answer your question, no, I don't write Go for work other than just write articles or do presentations and things, but not on a day-to-day basis, unfortunately, anymore. I have in previous lives really like Go a lot. So I'm going to stay in the Go world as long as I can. Look at this stuff, just ripping and roaring on a 10-year-old computer. I'd like to remind people, because I can see that new people are coming into the chat, that this is a 10-year-old computer. This is a 2011 Mac Mini that I'm on right now. Ringo Mar says, just starting Golang this month, looking for any tips. Here's a tip that I gave out earlier to somebody else in the chat. I'll find it here. This is how I started out, and it wasn't even that cool when I started out with it. I should ask, have you done the tour of Go yet? I should probably ask that first before I send it, because maybe you've already done it. I'm gonna ping it. The tour of Go is awesome. I'll drag it over here. So with the tour of Go, here's one of the interesting things about Go. So I've learned a bunch of languages. I know that I'm not sure that anyone really super cares about my history, but my history has been with a lot of different programming languages, a lot of software development. And Go is a little bit different than anything I've ever done before, because Go is extremely simple. Like the core elements of Go, there isn't a lot to learn about it. However, writing good Go code is incredibly complex and difficult. So you can get to writing things really fast, really simple, because it's just not a very complex language, which is good for learning. But as you're going, you know, I'm constantly learning. I don't even call myself a Go expert because I'm constantly learning, and I'll look at something and be like, oh my gosh, that's awesome. I can't believe I didn't think of it doing it that way, etc. But anytime someone says, I just want to learn Go and I'm starting out, should I learn it? I always try to push it because it's so simple. There's not a ton of stuff to learn to get going and get your feet wet and to build things with it. However, it is a constant learning process to write good Go, which is great. So the tour of Go is an interactive Go prompt. As you can see, I brought this up earlier, where you can just put Go in to here. So if you're super comfortable with it and you've installed Go on your machine and you're running it, that's cool. But this does it all in a web browser, so you don't have to install it, but it has all these different little exercises. So it shows you how to do imports. It shows you how to to functions. We've been working with functions a lot, and we have these input parameters, return parameters. It shows you how all that kind of stuff works, and you go through, and it's pretty awesome. I would highly recommend it, because once you go through the tour of Go and you get a good grip on that and understand it, you'll be able to just dive in and build stuff. Like, you can build all kinds of stuff. So yeah, it's the simple yet complex language is how I would describe Go. And I really like it for most of the reasons that everyone else likes it. It compiles fast, it's concurrent, it's fast performing, it's just a lot of fun. Repos, hot car. Did I not create a database? Cancel. Open database. Oh, there we go. Readings.db. Ta-da! My gosh, it actually worked. Amazing. So, in this stream, in this hour-long something stream, we've managed to achieve the goal that I set out to do, which is take 4 CSVs with 4 separate data streams. Let's take a look at it here. 4 separate data streams and combine them into a single database with humidity, Fahrenheit, Celsius for each of these. So this was a project that I did a while back where I took a Raspberry Pi and I put it in a car with the windows cracked like 2 inches, and I took a Raspberry Pi and I put it outside under my deck, and I just compared the two temperatures for a few days during a massive heat wave in Oregon, where it got up to 119 degrees. And I've just been playing with that data for a couple weeks now, and this is part of it. So it's all in this database. And now we have Celsius and Fahrenheit, which I got a few emails, and I got somebody on Lobsters who was like, why not? Why not Celsius? So now we have Celsius, which makes sense. That's what the scientific community uses. It's what the rest of the country, or the rest of the world uses. Our silly country with our imperial measurements and Fahrenheit. Yeah. That's why I originally did it in Fahrenheit, because I live in the United States, and the United States people will relate to it a little more. But now we have it in Celsius too. This is all on GitHub. Had a GitHub here. GitHub.com, Jeremy Morgan, Hot API, or no, Hot Car. I put in Hot Cat, that would be horrifying. Okay. Drag it over here so you can see it. So if you go to github.com/Jeremy Morgan/hotcar, I will commit all of these changes that I've done tonight. As you can see, 8 days ago is from the original stream, but this, with everything in this repo, you can just run this Go application and it'll pull in all of these CSVs. So I've given out, and this is the real data that came from the Raspberry Pis. Read in the CSVs and put them into a database, which was named test database, but now it's going to be named readings. And as you can see, it's actually pretty fast. It didn't take very long at all. We'll just delete this again and run it. And it's going to go through and it's going to rip all the data out of all those, stuff them all into this SQLite database. And that same SQLite database, since we've refactored this so much tonight, I'm going to have to refactor the Hotcar API, but that's fine because I need to do more stuff with the Hotcar API. And as long as people are watching this and think it's cool, I'll keep working on this project. I honestly didn't think that this was going to be as appealing to people as it has been. So I just kind of thought, well, I'll do this silly thing and we'll see if anyone likes it. And turns out a lot of people like it. So it's interesting and it's fun. The Hotcar API is an API on DigitalOcean, which accesses this data through REST API. I'm going to add some more stuff to this. I'm going to attach a front end to it. We'll do it in Vue and or Blazor and .NET to put a kind of a front end on this data so that you can just kind of go in and say, give me all the temperatures for this day, give me the hottest temperature for this day, whatever. Go over here to Twitter and show typing's a little slow. 10-year-old computer again. We'll show kind of a picture of these Raspberry Pis that we set up. Yeah, this is kind of going a little slow with the Go program running in the background and streaming and everything. It's going a little slow. Oh, look at that. This is what I should have done tonight. I should have done everything in this cool retro term. So ignore all of the stuff. There we go. There's a hot car. So I took a Ford Focus, rolled the windows down about that much, which is probably 2 or 3 inches. And then measured it versus the outside temperature, which, as you can see by this GIF, this is what I posted. It's insane. So yeah, Oregon had a giant heat wave during this time, 114, 108. You can see different temperatures. Got up to 165 in here. And Ringo Mar says, the only thing I don't really like about Go is the if statements for errors. Yes, I agree with you on that. I agree, mostly because when you start to write something big like what I'm writing, it starts to get a little repetitive and silly. If error equals nil, log for error. If error equals nil, which you can abstract this into a function, but still you're calling that function every time. I do like the way C# does it, where you do a try catch, and Python and things like. I do like try catch, where it's like we're going to try this thing, and if not, we're going to spit out this error. I can make try catches look a lot cleaner, and I know that a lot of people are not big fans of try catch, but I feel like I can make try catch look a lot cleaner and a lot more easier to understand. But I agree with you. I don't really like this. If error is nil, do this. Because I've repeated this code 50 million times, and even if I extract it, then I'm repeating that method call, and yeah, I'm not a big fan of it either. I do like try catch a little bit better. For some reason, a lot of developers hate try catch though. So, and I can understand when you do a try catch in C#, like if you say try catch error EX, and just catch any old error and spit it out. That's pretty clean, but there are times where you're like, oh, I need to do a file exception error, or I need to do memory error, or, all the different errors. And it's like try catch with this huge list of errors. That can get pretty ugly as well. There's no super great way to do it, but I also don't like repeating this stuff over and over and over. So we ran this again. Let's open our database again. I feel like we accomplished this pretty quick. When I first started the stream, I was actually thinking of doing 2 separate tables or 2 databases or whatever. I actually do like this way better, just doing it all in one single table. And realistically, this is how you convert Fahrenheit to Celsius. We have right. If I can even find it. Remember, if temperature, this is how you can convert back and forth with Fahrenheit and Celsius. Really, if it's one or the other, if it's only Celsius or only Fahrenheit and you're using this for an application, you could throw this in here. But by us doing it in the database, we've thrown those few cycles that it takes to do that, and we've absorbed that into our database. So I think it's good that we have both Fahrenheit and Celsius, if that makes any sense. Like, I could easily say, hey, it's in Fahrenheit, so if you want Celsius, do this. And you could do that with JavaScript. You could do it with Node. You could do it with what the heck ever, and that'd be fine. But then you're passing that work, right? You're passing those cycles. So that's sometimes one of the things you have to think about when you're developing web development and desktop development is where are you passing those cycles to? Who's handling the cycles? Right now, I'm handling the cycles, right? My Mac Mini is crunching this Celsius and storing it into a database. The database is bigger. I'm also absorbing that. So I'm absorbing a little bit of disk space and some cycles that the user of my application does not have to absorb, if that makes sense. So if I said, you want Celsius, convert it yourself. You want Fahrenheit, convert it yourself. It's perfectly fair because it's this simple thing. But then all of a sudden somebody's building an application and their React app has to do this calculation. Might be a fraction of a second slower, and the user has to absorb it, or their application has to appear slower. So Ringo Mar says, here's one question. How do you go along importing modules or like an external Go file with functions? We're doing that here. The Real Mitchell says, so lots of try catches versus lots of ifs. Yes, absolutely. So one of the things I'm doing here, Ringo Mar, is I have a data layer package. So I created a folder named data layer. I say it both ways. And I've created package data layer. And all this thing is just a list of functions. It's not actually like if you're thinking of an object-oriented language or something like that, this is not a class, it's not an object, it's just a list of functions. I could easily copy and paste all these and put them into process.go, but I just kind of wanted to separate them in the source. And so the way I did that was I did package and just created a new package called data layer. In that package, we import these things, the Go SQLite library, log, OS, and then up here, I have github.com/jeremymorgan/hotcar/data layer, which this is a fake aliased name. I could call this whatever.com/whatever. It's in my Go mod here. github.com/jeremymorgan/hotcar. I don't expect anybody's ever going to use this data layer for any reason, so I put it in. But yes, to answer your question, you can do an external Go file with like functions. You can even compile it into a binary and call that binary with Go by using these packages. This is the best way that I know of to export these out. And I like to just kind of separate things. Like I wanted to make a data layer that's only data stuff. I violated that a little bit tonight because I did some data stuff down here, but for the most part, process.go is just managing things. It's reading CSVs, and the data layer is managing the data stuff. But in the end, it's all a big list of functions. It's basically like a procedural program from start to finish. So I've set out tonight to accomplish something, and I've accomplished it. And yes, Real Mitchell says if you do a Go get package name, it will manage Go mod. So this isn't an actual package that somebody would ever use, but if it were, I would have to prepare it a little bit differently. I just basically wanted to throw a few functions in a different file. So as I'm looking through this, for those of you who know Celsius, not sure why it's not auto-completing for me. Select max, car temperature, Celsius, from reading. So those of you that think in Celsius, the maximum temperature in that car was 77.1 Celsius. Oh, auto completion only after you specify the table. I've been using the CLI a lot with this thing in the past. Like I did a bunch of SQLite database work in the past, and I did it with Python. I did so much stuff with the CSV. The SQLite Explorer is awesome, or DB browser is awesome, but I still kind of getting used to it. And I'm not even, let's see, outside temperature. Thanks for that tip. Because, yeah, now that I see that's from reading, does DataGrip do SQLite, I wonder? I wonder that too, and we'll find out right now. So there we go. Max outside temperature in Celsius was 48.8. And the car temperature was 77.1 during our heat wave, which hopefully we don't have another one that we can look at. Let's open up DataGrip, and see if it does SQLite. Because I don't know, I installed it earlier today just to throw it on here for whatever. And I haven't actually used it, as you can see. So I'll probably have to sign in. Yep. Sign in really quick here. All right. Strange that it just disappeared like that, but there we go. Okay, so I'm signed in. We'll create a new project. Hot car. That's what I've been calling this whole thing because I'm not good at naming things. Loading hot car project. Create data source. There it is, SQLite. Identifier SQLite. Okay. Oh, I gotta download SQLite drivers. Like that says click fix. And SQLite, comment. Looks like this is all in memory stuff. And, whoops. I screwed that up. Properties. Download missing files. Test connection. I might use DataGrip next time I do this. Now it looks like I can. But I don't know how to actually make it open that particular database. This is kind of interesting. General. File. Yeah, I'm not really sure how to load up the file. I'll have to play around with that. Never really used SQLite for this. And yeah, now I pretty much, like I said, I've achieved the goal that I was looking to achieve when I started this. And now I'm looking for more ideas. So any ideas any of you might have on ways we can expand this a little bit? One of the big ideas was make it Celsius. And then, of course, make an API. So we've got an API for it that needs to be worked on, and that's something that we'll jump into again next week. We'll start making some more API stuff for this thing, including now Celsius and Fahrenheit. And then I'll attach a front end to it. Ideally, I think it'd be cool to do like a Heroku thing. Or I can probably do it on DigitalOcean also, where I have like a Vue app that ties into this Go API, and it's all one bundled nice little thing where I just go to a URL and load up the Vue app or Blazor. I would like to do like a Blazor WebAssembly app and just have it nice and bundled so that you could just go there and say, what's the hottest temperature? What was the temperature difference between the car and outside at this time? What was the temperature by day, etc. So we'll figure that out. But before I sign off, let me see how long I've been on here. Wow, 1 hour and 52 minutes. So I'll sign off at exactly 2 hours, I guess, tonight, which is fine. So how about I show you something here? As a reminder, Hotcar API and Hotcar. So github.com/Jeremy Morgan/Hotcar/Jeremy Morgan/Hotcar API. And another reminder, one of my Twitch followers is going to get this Raspberry Pi 400. So all you got to do is go on to Twitter, Jeremy C. Morgan on Twitter, and we are going to give away. I'm going to give away one of those things to, when I hit 500 followers, I'm going to give away one of those things to somebody who has retweeted that tweet and follows me on Twitch. So if you go to Jeremy C. Morgan, right there, retweet this, follow me on Twitch, and you'll be entered to win. Probably going to give away a few of these, I'm just saying. Probably going to do this a while. As you can see, I got 99 likes and 74 retweets, so I'm just going to keep it going. Trying to build up the Twitch audience, trying to get as much exposure out there. And the Real Mitchell asks, does Pluralsight ever collaborate with companies for recruiting? I'm not 100% sure on that, but if you want to email me, I can find out for you. Email me, jeremymorgan@gmail.com, and I will find the answer to that question. Because I'm not really sure. What was the last thing I was going to show? 8-bit emulation, which I may come back on here and do tonight. You see some of the things I've installed on here? You can tell what I'm going to do with this machine, right? So I decided to use this machine for streaming tonight, just to see if we could stream on a 10-year-old machine. Turns out you can, mostly, sort of. We're streaming at 720p, which is doable. But where is it? But I'm also going to play around with other types of development on here. So I've got CLion installed, PyCharm Professional. I may just use this just for a streaming machine to just pop up and stream something in Pop and present something. I don't know. I haven't really decided. But I've also got Xeneus Hegon something. I'm not really sure how to pronounce it, but I installed an 8-bit emulator on here too. Oh, and Robocode. So it might be kind of cool to do a Robocode stream. I haven't done Robocode in so many years. If you've ever done Robocode, it's fun. Make these little tanks battle each other. Anyway, let's see how well this works. Hero is the name of it, right? Test. Maybe it's ZNES. I don't remember which emulator. I just spent like 5 seconds on it. This one doesn't look like it's really doing anything. Real Mitchell says you should do Battlesnake too if you're into Go. I have not tried Battlesnake. There we go. Load up ROM file. The best game in the world. Mike Tyson's Punch Out. Ding, 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 ding. Let me Google Battlesnake really quick. See what I have this. All right. Thank you very much for that suggestion. Program your Battlesnake and compete online. I already like the sounds of this. Really fun programming side project. Looks like it's the same kind of thing as Robocode. Heck yeah. I'll even follow on Twitch. You bet. So yeah, I'll look into that because that might be kind of cool. Got my little controller here. Let me turn off the music really quick. Because I'm going to come back later and listen to this and see if the sound is screwy. I think it, whoops, I think it might be. Push start. Actually, the sound isn't too bad. A couple hours ago, the sound wasn't that great, so. FPS 58, not bad. This controller's not working. I'm gonna get beat by Glass Joe. What is up with that? Watch him just pound on me now. Controller. I can't even pause it, so he's just gonna beat on me. So let's see, mapping up. Down, left, right, B, looks like it's select, start. Interesting. Looks like it was all configured. Thank you, Real Mitchell. You also have a good night. And I really appreciate you coming onto the stream, and I appreciate you showing me Battlesnake. I have a feeling I'm going to really like Battlesnake. It seems like it. Yeah, this isn't working very well, so I will have to mess with that some more. For those streams, I'll probably give everybody a heads up that, hey, I'm going to play these ancient 30-year-old video games during my stream. But the next stream that I plan on doing, that I plan on doing, is on Monday. And I'm going to do Blazor and facial recognition stuff. I wrote an article about it a while back. I've been messing with it for a while. I've been playing with it. And we're going to do that on my Windows machine. We're going to create a new Blazor app that uses Azure Cognitive Services to do facial recognition. It's very cool. It's very fun. And we're going to be doing that Monday at 4 p.m. Pacific time. Pretty excited. I may do another stream this weekend. Probably not. I have no idea. It just kind of depends. Like last week I planned, with my streams, I want to do Monday, Wednesday, and possibly Friday. That's kind of the cadence that I want to do. And Monday I want to do .NET and Windows stuff. Wednesday I want to do Linux stuff, and then Friday kind of do whatever. Last week was a wild week for me, so I wasn't able to do Wednesday or Friday. I was only able to do Monday and Tuesday. and today. So that's kind of what the plan's going to be, though, is like Monday, Wednesday, maybe Friday, and possibly weekends. Anything on the weekend is a total bonus, like today, where I just open it up and start doing things. I'm going to work more on this this hot car project. We're going to do some Python computer vision stuff. We're going to do some Azure stuff. We're going to do some Blazor stuff. All over the place. So follow me. When I reach 500 followers, I'm going to give this thing away. So follow me, retweet that tweet. Just kind of trying to build up my audience. I don't want to do this for a living or make $1 million. I just have a lot of fun streaming and talking with people and interacting. And I want to keep that going and make sure that this hits the biggest audience possible. So I want to say thank you very much for checking me out. Follow me if you like this stream. If you're watching this stream later after the fact, still follow me. Give me feedback, jeremymorgan@gmail.com. Tell me what you think. And yeah, just want to say thank you for everybody for enabling my stream. This has been a lot of fun. I've had a lot of fun. I'm going to commit this thing to GitHub. On my next stream, I'm going to use the Cool Retro terminal for all my coding, right? I'm going to go in here and say repos, hotcar, bim, process.go. And I'm going to do all my code editing like this. Totally kidding. Absolutely not. But wouldn't it be cool? You know, that's what I tweeted out. Like, wouldn't it be cool and annoying at the same time if I did an entire live stream coding in this terminal? This is the kind of terminal, this is the stuff that I stared at in the 80s when I was trying to figure out what the heck I was doing. I wouldn't subject people watching to this, though, because this is going to, I don't know, this would drive me crazy. So just writing in it. So I think it would probably drive everyone else crazy doing it, but it is kind of cool looking. It's a cool looking terminal, right? So anyway, thank you everybody for joining my stream. I really appreciate it. I will see you soon. Follow me. I'll follow you back if you're doing cool streams, and I'll watch your streams and I'll raid you when I have enough people on my channel to actually do a raid. Anyway, thank you very much, everybody. Have an amazing night.